Number 10, taken from the A-level past paper C2 January 2009. A solid right circular cylinder has radius r and height h. So this is a circular cylinder. So this is a circular cylinder whose height is h and its radius is r. The total surface area of the cylinder is 800. So since they didn't mention anything about if the cylinder is closed or open, we're going to assume that it's closed. So the total surface area includes the two circles, these two circles, and this curved surface area. So all of that is 800 centimeters squared. So it's made up of 2 pi r squared, which is the area of two circles, plus the area of curved. The area of curved is the rectangle. So if you open this cylinder, you're going to have something like this. So it's a rectangle with a length, or with the height. This is the height h, and with the this is the height, this is the width or the length, which is it resembles the circumference of the circle. So this resembles the circumference of the circle. So what's the circumference of the circle, or the length of the circle? It's 2 pi r. So in other words, it's 800 equals to 2 pi r squared plus 2 pi r times h. Now we need to continue reading the question. Show that the volume V centimeter cubed of the cylinder is given by this formula. So now we need to find the value of V, the volume of this cylinder, such that it only contains r and pi. So if we're going to find the value or the volume of the cylinder, it's going to be equal to the area of the base, which is the circle, times the height. Now the area of the base, which is the circle, is equal to pi r squared times h. But if you look at what they want us to reach with respect to the formula of volume and what we have here, it's completely different, because we have h in this formula and we don't have h in here. So we need to replace h and then start working to get to reach what they want us to find. Therefore, since we already have the value of the area, the value of the total surface area, so we try to make h the subject and take everything to the other side. So we reach 800 minus 2 pi r squared divided by the coefficient of h. Then you find that you can divide by 2, because we have 2, and here we have 2 times 400, so we can divide up and down by 2. So the answer for h is 400 minus pi r squared over pi r. Now, in order to find the volume, we already have pi r squared. Now we replace h with what we found. So h, we replaced it here, and then we expanded. So when you expand, or we don't really actually expand before we simplify. So you simplify the pi and the pi, because here you have multiplication, and the r squared, and here the r is r squared divided by r remains, so you multiply r inside to every term, so it's 400r minus pi r cubed, and this is what they want from us. In part B, use calculus to find the maximum value of v to the nearest centimeter cube. So now you need to work it out or use calculus or the procedure in order to find the maximum value of the volume. So first you find or you put v prime, and to get the maximum, you need to have the stationary point happens as the derivative is 0. So you write v prime 0 and then you solve for r. So r squared is equal 400 over 3 pi, therefore r is equal to plus or minus square root of 400 over 3 pi. But since we're working with radius, therefore we only take the positive, which is the positive value, which is 6.5, two significant figures. Now we still didn't finish because we need to find the volume. So you replace r in the initial value here, in the initial equation, and you get the value for the volume. Now in part C, they want you to justify that this volume that you found is the maximum volume. So you need to derive again. So the derivative that you already used is this one. So you take it and you derive again. When you derive, which is the second derivative, it's going to be minus 6 pi times r. Now, when you replace r in here, you're going to have a negative number because you know that r is a positive number and we already have a minus here. So you just replace r, and even if you didn't replace r, definitely any positive number multiplied by a minus is going to be negative. Therefore, since the double derivative is negative, the maximum, the volume is maximum at or when the radius r is 6.5 centimeters.